This is insane to me. More than 100 frames per second on CPU, absolutely blowing my mind right now. Hey everyone, and welcome to another video. So Meta, the Facebook company, they came out with DINOv3, distillation with no labels. The models are state-of-the-art, self-supervised vision transformers, and I've been looking into those and been using them for training my YOLO models, or rather pre-training my YOLO models with distillation. So DINOv3 is absolutely bonkers to me. Just look at the FPS that I'm able to get after distilling and then fine-tuning my YOLO models. So down here on the x-axis, you will see frames per second, and then the mean average precision, 50 to 95 for the pose estimation. And the blue colors are the 8-bit quantized, and the orange are the 16-bit quantized model. And they're optimized here for OpenVINO. So for example, this would be CPU optimized, and then TensorRT is the GPU optimized version. I also have the Onyx version for the GPU. It's not very well optimized in my opinion, so it doesn't really produce a lot of the upside that I'm looking for. But regardless of that, the small models, after distilling the knowledge from DINOv3, then fine-tuning my YOLO models, and the Nano models themselves are producing close to 700 but more than 600 frames per second with the GPU optimized TensorRT version. Even on the CPU, I'm able to get more than 100 frames per second. This is insane to me. More than 100 frames per second on CPU optimized YOLO Nano model for pose estimation. Absolutely blowing my mind right now. So in this video, what I'm going to do is I'm going to go over this repo that I've set up. Here's my code. This is the Python code that I've used to distill the knowledge from DINOv3 or DINOv3, however you say that, into a YOLO model to pre-train it on unlabeled data, meaning I'm not labeling any of the images. DINOv3, whatever you say, however you say it, it is doing the feature extraction and training or pre-training my model, the smaller YOLO model or more efficient YOLO model, and it's training it to learn basically how DINOv3 looks at the images. And then after that pre-training is done, I'm able to fine-tune the YOLO model, and this is what you can see over here. On my GPU and my CPU, I have a i9 CPU. GPU is 4080 Super, and these speeds and the accuracies our precisions are not that bad anyways for the Nano model, but with the half precision and 8-bit quantized large model, the precision doesn't decrease all that much from the 32-bit model. So I'm just blown away by the speed that I can get from just even the 8-bit quantized or the 16-bit quantized versions of the YOLO model after fine-tuning them. Everything that you need to know is down here in the instructions, with some code snippets to sort of help guide you. All right, so with that out of the way, I'm going to do a very quick demo of this for you guys. So you see that the distilled and then fine-tuned model is absolutely just insane to me. So I'm going to be using this Nano model, and I will use the CPU version because I'm using OBS, and I will show you right now without anything running. OBS is taking up majority of my GPU, so I'm going to be running the CPU quantized YOLO model. Let's go ahead and find a good video to play here. All right, so I'm not going to be saving the output from this run, but I will show this so you guys see it in real time as it's happening. And if my past experience is anything to go off of, this is going to go fast. It's incredible. The device is going to be CPU. So this is how crazy fast the inferences are being done. So look there on the right side, under my under the outputs here on the command line interface. The speeds are insane. 5.4 milliseconds, 6.1 millisecond. This is happening on a CPU. This is incredible. My GPU is being consumed by my OBS, but the CPU is about 36%. So if I wanted to batch process these and make it go even faster, that's doable. That is absolutely doable. And in fact, let's try that out. I haven't tried it out. I'll do batch size of 10. And even with batch size of 10, the speeds here are just crazy to me. This is incredible. 4.9 millisecond. Like, what is going on? This is on a CPU after model has been distilled, and it was fine-tuned, and this is a nano model, and you can see the jitteriness is not so much. It's just it has learned to do feature extraction very, very efficiently from the DINOv3 foundation model. So I'm going to stop it right here. And that is it for this video, and I'm just sort of blown away that this is possible. And down here you can see the 5 millisecond inference, 2 millisecond pre-processing, 0.5 millisecond post-processing. And this post-processing is because I'm not saving anything. This would likely go up if I was saving the outputs, which would take a little bit of time to save. But here, 5 millisecond inference time, absolutely just mind-boggling to me. Earlier, I could get this one with some pruning to less than 2 millisecond inference time, and that was just blowing my mind. Okay, so I'm like a kid on a sugar high right now. It's you don't see these kind of leaps so often, so that's just why I'm excited about this. Okay, so I'm going to leave the video right here. Thank you so much for watching. I hope you will find the Python script to be helpful. If you have any questions, please reach out. I would love to hear from you guys. How are you using these things to benefit your research or your life? Let me know. Thank you.